Hi, how's everybody doing out there? This is W8JD, and I want to show you my latest project for interfacing the ICOM IC-705 to the Xiegu XPA 125B linear amplifier for remote Bluetooth band switching. In my previous project, which accomplished essentially the same thing, I used an Arduino module, an Arduino Uno, with some external modules to accomplish the interface. In this case, I'm using the ESP-32 module, which has the Wi-Fi built in, the Bluetooth built in, the DDA converters built in, the ADD converters built in. Also has multiple I2C ports and multiple SPI ports. So yeah, it was perfectly suited for this interface. So I'll put you on hold and I'll show you what I have. Quick overview here. This is the ESP-32 module here, and it's mounted to a development board. Now these, I think I mentioned this before, but these came in a 3-pack. I bought 3 boards and 3 development boards all came in a 3-pack for around 20 bucks. Very inexpensive, and of course I didn't need any DDA converter, and I didn't need the Bluetooth module. It's all built on. So the ESP-32 board, one of the disadvantages is it does not have a 12-volt power supply like the Arduino Uno does. This is an Arduino Uno form factor, so actually it fits in the same case. So you can plug the 12 volts in from the Xiegu amplifier here. It has a 12 to 5 volt converter here, which runs the board. So in this case, I pretty much had to use the board anyway. Yeah, so let's see. This is the an I2C port output that for a little 64 by 128 OLED module that I just put on here with double-sided sticky tape. But this whole project I put together in less than 2 days from the time I got the board, including writing the code. That's how simple this went together. There really is any wiring to speak of. This cable goes out to the XPA 125B amplifier on the 6-pin mini DIN plug. I picked up 12 volts off of the to feed the board right at the plug. This is my keying cable, just like before. I have not put a buffer relay in here. I'm keying the XPA 125B directly from the IC-705. I haven't had any issues. I'm not sure if I really don't have a lot of room in here, but I haven't had any issues. The IC-705 keys the XPA 125B perfectly. Yeah, so that's pretty much it. This just passes through. Right. Of course, the push-to-talk line is on this 6-pin DIN plug, as well as the channeling band switch information. So since I have one input, I went ahead and put it into my module and back out the module to the XPA 125B. Pretty straightforward stuff. I'll put you on pause again, and we'll get it fired up. Okay. Since my module gets its power from the 12 volts output from the XPA 125B, as soon as I turn on the XPA 125B, you're going to see my module light up here. So I have a splash screen on here. Bring it up a little closer here. I made this cable too short. That's what happens when you get in a hurry. So the splash screen just comes up and says IC-705 /XPA 125B version, in this case version 1.00A, May 10th, 2025, waiting for Cat 5. So I'll turn the IC-705 on next. As soon as this IC-705 boots up, you may or may not see for just a brief second the splash screen for the right there. You'll see it for just a second. That's how fast it connects. Sometimes a couple of times I haven't seen it at all. So as soon as you start to tune, just like with my old module, you'll see as soon as this will start outputting Bluetooth, boom, it just switches over to my new screen. The new screen displays the frequency. It displays the band on the second line, as well as the desired output voltage out of the Zygu manual, which in this case 40 meters is 0.92 volts. And I'll tell you one thing about these ESP-32 modules: the DAC is not as accurate as the standalone modules. And it would have worked anyway. They're accurate enough. It would have worked perfectly, but I decided to go ahead and just tweak the DAC voltage so that I got the exact voltages out. In the case of 40 meters, I had to set the DAC to 0.9 volts, which gave me the 0.92 desired volt out. On the band edges, it was a little worse. I think this is 160 meters was about the worst. It wants 0.23 volts. I had to put it at 0.15 volts. It was still close enough. I tested this before I put any correction in. It tuned all the bands fine, so you really don't even need to do this. I was just kind of learning this module. I went ahead and did it and displayed it just because I could. You can see that everything is instantaneous. It'll switch here, here, and of course here. 40 meters, 30 meters, and also the tuning is instantaneous. It repeats the IC-705 perfectly. And actually on my Arduino module, if I really got cranking on this with this on high speed, a couple of times I had the Arduino module hang up. I'm not really sure why. I actually had to reset the Arduino module. I almost couldn't get it to do it at all, but it did do it a couple of times. This one, however, I've never had a glitch. It's just solid as rock. I assume that's because of the faster processing. So the 50 I'll show you here. The correction on the band edge here, 6 meters. Zygu wants to see 2.53 volts. I had to set the DAC to 2.63 to get it to be perfect. Around the middle, well, yeah, there's no correction. 1.38 is 1.38 on 20 meters. So yeah, you really don't need to do these corrections. You'll see it in the sketch, which I'm going to show coming up next year, where those voltages are listed and where you can put the corrections in. Also, by the way, the sketch uses the same Arduino IDE, so yeah, makes life real easy. You can do it other ways too with the ESP-32 module, but you can do it with the Arduino IDE. Now this does not have a hardware COM port in it, so you have to use a virtual COM port in the ESP-32 module, so you'll have to go to Espressif website to download the proper driver for your COM port, virtual COM port driver for your board. In this case, and I'll show you that as well. Actually, I'll show you that when I get to the sketch. I'll actually show you the where I purchased it on Amazon, and it'll have all the information listed there. So we'll get to that next. Not much else to show you here. So I'm going to put you on pause and we'll go to the sketch. And quickly, while we're still here, as far as the wiring, I didn't mention this pin. This is the analog output. It comes out on pin 25, which is right there on the ESP-32 board, which also repeats comes out right here. And that again just goes right out to the 6-pin DIN plug in the back of the XPA 125B. Okay, so this is my sketch. You'll notice at the top here, I use the ESP-32 WROOM DA library that you can download. It's part of the Arduino IDE package. You can go in there and select your board. In this case, mine was the WROM module, which seems to be one of the most common modules in this ESP-32. There are several different versions. This worked perfectly right out of the chute. Again, I asked ChatGPT to write the sketch for this initially. It did a really good job this time. And then I went in later and asked it to provide detailed comments, which is what all these are. Did a good job at that too as well. A couple of things to note here at the top. My ICOM, the IC-705, the default the address was set to A4H on the Bluetooth. This was something else the way it was written from in the original sketch uh, from Chat BPT, but so I went ahead and changed this to A4. You just ignore the H. The OLED display address was correct. Worked right out of the chute. This sets up the parsing for the band select, which is all down here. I wanted to show you this. These are the bands. Is what actually comes up on the display in the second line. Uh, Again, the Chat BPT just put the amateur portions of the band in here, which I did not like because if you were anywhere out of the amateur band, it just went off into I think 160 meters or something. I didn't like that. I'd rather have the filters be close all the time. So it's continuous here from 0.8 megacycles to 60 megacycles. You'll always be selected close. Okay, these are here are the desired voltages out of the Zygu manual. These are the voltages that I had to input for this particular board. Each board, I have 3 of these boards and I tried them all and they all took a little bit different voltages tweaks to here to get these exact voltages on DAC output. So just keep that in mind. I did not need to tweak them. Yeah, I tried it with all these voltages default. They were just set to what these are. And of course, the output voltages were off a little bit, but didn't bother the Zygu at all. It channeled just fine. So um, this is really not even necessary. Maybe some boards will be so far out that you'll need to do it, but if you want to do it, this is where you do it. Rest of this is pretty well Arduino stuff. It's all documented here. I think I got about 160 lines total on this sketch. Pause here a little bit. This sketch is published on it's published on my page W8JD at GitHub. So yeah, it's all there, so you don't have to sit here and type all this in. Hopefully. Also, the sketches for the Arduino version are there too as well. Let's see. A lot of this stuff you don't even need if you're not going to use the display. This is all obviously display stuff. It also outputs on the serial monitor for the Arduino IDE. You could cut the sketch probably in half if you didn't care about all that stuff. But I had plenty of room, plenty of memory, and want to learn a little bit about the board. This is my first exposure to it, so I went ahead and put these extras in here. Okay, I'm put this on pause, and I'll show you the actual board that I bought. Okay, these are the boards that I ordered. You'll see here that they're the ESP-WROOM32 version. There are several different versions. This seems to be the most popular. I'm still getting familiar with this board. Again, these boards do not have a hardware COM port on them, so you'll have to create a virtual COM port, which you have to go down to the Espressif website and download the proper COM port, virtual COM port for your particular board. After you do that, it'll just come up on your device manager. You'll see, in my case, it said COM9 virtual port, and you're good to go. The boards themselves, you can see here the ESP-32 board plugs into the development board. The development board has the 12-volt power supply built on here, which is why in this case, I needed this development board to be there because I only had 12 volts coming from the XPA 125B. The link is on this video at the bottom. You can cut and paste that and go to my it takes you to my GitHub page, W8JD, where all these sketches are listed for both the Arduino and the ESP32 module. Okay, that's all I have.
So this is W8JD. I'll be saying 73s. Good luck. Don't be afraid to leave comments. I do check my page pretty much every day. So far I haven't had any comments. So I guess there's not too many questions. Be happy to answer them. W8JDs and 73s.